Hey guys, so the reason that I had you do the opposite function homework was because I wanted to see what you guys thought an opposite of a function might be. Some of you might have flipped it on its head, some of you might have rotated it, some of you might have reflected it, and I want to see what you thought that opposite function might look like. So that was just kind of an exercise for me to see how you think. There's no wrong nor right answer really. But if you did guess that the opposite of the function was going to be a reflection of the original function, you might have gotten it right. So today's lesson is going to be about inverse functions. So what does an inverse function look like both on a graph as well as on a table? So we're going to define it, and it's going to be kind of an informal definition. Then I'm going to go through the whole notes in this video so that you guys can do it in class, and then you'll probably get to do your homework in class as well, because I don't think it's going to take as long as it would if I were there with you. So an inverse function, first thing I'm going to do is define it for you. All an inverse function is a reflection of the original function. I'll show you guys specifically how that's reflected now. So on this graph, we're going to draw a simple, you can draw a triangle, you could draw a square, you could draw a rectangle, whatever. You're going to draw a shape. You're going to do it in the second quadrant. And I just want to remind you guys that the quadrants are labeled quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, so we're going to be working in quadrant 2. That's over here. All right, so I'm going to do a triangle. I'll just draw a triangle in quadrant 2. All right, so here's my triangle. It's a relation, right? It's not a function, because if it were a function, then there wouldn't be any inputs that have two outputs. And the way that we can prove that on a graph is by checking for the vertical line test. You can see that there are a lot of vertical lines I could draw where I would hit this triangle twice. So we're dealing with a relation, but regardless, we're just proving the point here of what it does. So step 1 is going to be to draw the dotted line y equals x on the graph. So remember, the dotted line y equals x has a slope of 1 and has a y-intercept of 0. Remember that functions or lines like this are in y equals mx plus b form. So m is your slope, and in this case, that's a 1. And b is your y-intercept, and in this case, that's a plus 0, right? So it's going to start right here, and it's going to go up 1 and over 1, up 1 and over 1, up 1 and over 1. It's going to do that across the whole graph. All right, so there's the line y equals x, right? Y-intercept of 0. Slope of 1 over 1. And now we're going to reflect our shape over the line y equals x so that now it's in quadrant 4. So remember from geometry that what a reflection does is it maps every point from one side of the line to the other side. And each point is going to be the same distance from that line as the original point was. So I'll just show you here what that means. We're going to take, let's say, this point right here, and we're going to map it over to the other side of the line by measuring how far it goes towards the line. So it looks like we go down 1, 2, 3. So to reflect it, we'll just go 90 degrees this direction. 1, 2, 3. All right, so that's going to be our new point for the triangle. And I'll do the same thing with the other 2 points. So we've just taken each point from that triangle and reflected it over our line y equals x. And now we've got a triangle in quadrant 4 that's a reflection of the triangle that we had in quadrant 2. So this function, although it's not a function, it's a relation. This relation is a reflection of this relation over the line y equals x. That's what inverse functions are. They're reflections of an original function. And now let's add that to our definition over the line y equals x. So now you've got a pretty specific definition. You can take any function and find its inverse by just reflecting it over the line y equals x. And right now, you'd have to know what it looks like in order to do that. So in the coming lessons, we will be able to start doing this with equations instead of just graphs. At the bottom, it says summarize how we can graph the inverse of a function or a relation. That's just you rewording what we just did in your own words so that you remember in the future. So I'm going to leave that space up to you. Make sure you fill that in, because these are your notes and you want to remember how this was done. All right, moving on to page 2. Page 2 of the notes is just some practice. So This is me showing you that tables work to flip all these points over that line as well. So they're another good tool for mapping our inverse functions. You don't just have to eyeball it, you don't just have to measure to the line. If you have the points, you can use the tables to map the inverse. So all I'm going to do is record the 3 points from the triangle that I just drew in this space, and you can use your rectangle or your square if that's what you chose to do. So these are the 3 actual points that made up my triangle. I'll just show you where those came from. So this point right here is the point -1, 2, so I put that in that table. This is the point -1, 6, and this is the point -4, 2. So I just took those 3 points and I plotted them over here in my table on page 2. And now what I want you to do is flip each point's x and y coordinate and record them over here. So what I mean by that is we've got point number 1, which is the point -1, 2. So when I put it over here in the f inverse of x table, I'm just going to flip the coordinates. So then instead of it being -1, 2, it's going to be 2, -1. I'm going to do the same with the other 2 points as well. And you should be doing this with your points because your points may be different than mine. Now if you look at these points that you just created by flipping these points, you'll see that these actually make up the shape that you made on the last page. So if I go back to page 1, I can just show you, if I label this second triangle that I created, if this point here is 2, -1, you can see that that's literally that point but flipped. And this right here is the point 6, -1. That's that point flipped. And this is the point 2, -4. Comes from that original point. So you don't really need to be able to see the graph because all you need to do is take each of the ordered pairs and just flip the x and y coordinates. So you're going to do some practice now. This is going to be a lot like what your homework is. It's a very basic set of practice. Using the given set of points, record the points that will map the inverse function in the table. Then plot both relations on the graph. So I'll start with f of x. I've got 1, 2, 3, 4. 4 points. So I'm going to take these points, and for each one, I'm going to flip my x and y coordinate and then put them in my f inverse of x table. So instead of the point 0, 3, I'm going to have the point 3, 0. Instead of the point -3, -2, I've got the point -2, -3, and so on. So now what I have is I've got f of x and I have f inverse of x, and it's really easy to do because all I'm doing is flipping the points. When you plot these on this graph here, you'll see that this is a reflection of this over the line y equals x. So all I've done here is I've plotted my f of x points in red and I plotted my f inverse of x points in blue. So just to illustrate, because it looks a little cluttered right now, just to show you the point that I'm making, let me just draw that line y equals x. Right here. So that's the line y equals x, and remember, the inverse of a function is just taking the original function and reflecting it. And now you can see that these 2 points are reflections of each other over that line. These 2 points are reflections of each other over that line. These 2 are, and these 2 are. So all we're doing is flipping the ordered pairs, and it's working the same way as when we were reflecting by just drawing. So let's do the same thing with the second exercise. F of x, we'll draw that one in red just to make it easy, and we'll do f inverse of x in blue. We're going to do the same thing. We've got 1, 2, 3, 4, 5 points. We're going to flip all those ordered pairs in our table, and then we're going to see when we plot them that these are reflections of these over the line y equals x. Now in this example, it ends up looking like f of x is a line. It kind of looks like that, right? Like you could connect them. Do not connect them. because these are just 6 points that look like they might form a line, but it doesn't say anything about what's happening in between each of these points, so you can't connect them. And the same thing is happening with f inverse of x. And again, if I draw in that line y equals x, you can see that one is being reflected over this line and becoming the other, right? Doesn't matter which one you start with, they're both just reflections of each other over that line. One important point here to take a look at is this point, -3, -3. Because it's sitting on the line, when you reflect it, it stays right on the line. So -3, -3. When you flip that point, it's still just -3, -3, right? In the table, still just that same point. So when you reflected them, you still ended up with just a point that's sitting on that line. So something kind of interesting with those points. All right, your homework is very similar to this, and I tried to keep this video short, but you guys should be able to get through this pretty quickly in class. It'll be much shorter than if we had done it as a lesson. So feel free to use this and the internet, use your phones, get this done in class, and I'll make a homework video right now that's going to help you get that homework done.